All right.
No, Tommy, you can't do that. You gotta know your limits.
I have no limits. Ugh.
Everything has limits,
I
even
got this.
someone as swole as you. Limits show the end behavior of functions.
All right. Well, how do you find limits then?
That's pretty easy. You just have to do a little calculus.
No, not calculus.
Stay with me here. Here we go.
Okay, there's an equation of your max which is a constant. No matter how much you lift today, your max will still stay the same.
Okay. How much stronger will I be tomorrow then?
Well, your change in strength is modeled by this equation, with x being the number of days that you train.
But that equation doesn't work for tomorrow.
You're
How
right.
much stronger will I be then?
There is a hole, but you can factor out the denominator.
Cool.
And you can find out that you got 2% stronger.
Okay, but what happens if you can't factor out the whole? Like if it was 5 over x?
Well, then that would just be an asymptote.
What's an asymptote?
Well, an asymptote is a part of the graph where it is not continuous or does not exist. As we see here, the asymptote for this graph would be 0 because the function will never cross or equal 0.
Alright, so what happens if I train for a really long time, like years?
Well, that equation would be 5x cubed plus 12x plus 35 all over x cubed plus 8x squared plus 2.
I really don't want to solve that though.
Trust me, it's not as hard since this is over a very long time period, and you only have to look at the end behavior. X cubed will be the only number that matters since over time the function will flatten out and you ignore everything but the highest power. So you could get 5 times as swole as you are now.
Alright, so what would happen if the numerator was higher power than the denominator?
Well then there would be no limit since it would go on forever. But if the denominator was a higher power, then it would just get closer and closer to 0.
But that function's really continuous. But when you're really working out, some days you hit plateaus and you're not making any progress. Other days you get sick, so you lose the progress that you made. Then other days you have like a great week, you're going at it, you move up so fast. How would that look?
Well, what it sounds like is you're describing a piecewise function. And that is when you have 2 separate functions on the same graph. And each of them have their own limits, which in this case is, for the first equation, it is x is less than or equal to 1, and for the second equation, it's x is greater than 1. And when you plug in these limits, you can find out if the functions are continuous or if they're not. And in this case, you can see that they are not continuous.
Hey, can we see it on a graph? That helps me a lot.
Oh yeah, sure. As we see here, we've graphed our 2 functions. X cubed plus 1, as we see there, and then 1, as we see there. And then, if we look at the limits, we see there that it is less than or equal to, and that means for that function, you put in a closed circle. But if it's just a less than or greater than, as we see here, it's greater than, you put an open circle. And then when you put them onto a graph, you can clearly see these 2 functions are not continuous.
But sometimes people ask you like, what's x to the 1 plus? What does that mean?
Well, when you see limit of x approaching the 1 plus, all that's meaning is just what is the limit as you're approaching from the right side. So in this case, you see here that when you approach from the right side, it equals 1. But then likewise, if it asks if you're approaching from the negative or the left side, when you follow it, it shows that the limit is 2. Looks like you really have learned your limits.
Let's go.